Okay, so the first two questions here are from yesterday's work, just adding and subtracting like terms and expressing in descending order of degree, so highest degree term down to lowest. Okay, so you do those right now. Okay, so first one, x cubed term, there isn't any other ones the same, so I'm not going to circle it. X squared, sign in front, include it. So there's two x squared terms, there's two x terms, and then a constant term, nothing like with it. So descending order of degree, I'm going to put the x cubed term first, then collect the x squared, so negative 2 minus 1 is negative 3. So it's the same as subtract 3x squared. And then positive 5x plus 7x is 12x. So plus 12x and then minus 6. Okay, so check your answer with that. The thing with algebra is you have to have really good attention to detail. So it's I always liken it to back or when you look for a job. If you ever look for a job, some jobs will, in the description, say what they're looking for, and part of it is good attention to detail. It might not be math stuff, but it's important for that. Okay, so next one. This is where it gets really important to be really careful about what are your like terms. So this is a b squared. So the squared is with the b. That's different from this term and different from this one, but it is a like term from this. So this one and this are like terms. So I just start at the left and look for any like terms with it. The next one, a squared b. Well, there's no other terms with a squared b, so I don't circle it. Then a cubed b and a cubed b. So this is a like term with this. In terms of the degree of each of these terms, so that's degree 3, okay? That's degree 3. This is degree 4. Degree 3, obviously, because those are like terms, and this is degree 4. So I'm going to put the degree 4 term first. So that's negative 1a cubed b minus 7 is negative 8 a cubed b. Then degree 3. So here you have a choice between the ab squared and the a squared b. So then you think alphabetical. Well, there's a's and b's in both of them. So more a's. I'm going to put the term with more a's in it. That's 2 a's. It's not wrong if you switch those around, but that's usually how you will see it. So I'm going to just copy out the 5a squared b because there's no like terms. And then 4ab squared minus, 4ab squared minus 10ab squared is negative 6ab squared. So that's going to be minus 6ab squared. Okay, so that's just adding like terms. So the only thing different today is you're going to have brackets in your expression. So you're adding polynomials. For example, here, this is a binomial plus a binomial plus a binomial. When you're adding, nothing really changes, right? Adding's easy. It's when you're subtracting. So these are all adding. When you're subtracting, though, you have to be careful of the signs. They will change. So that's why I've said here, remove the brackets and collect like terms. When you remove the brackets, the signs won't change because you're adding the polynomials. So these are adding only. So in this case, you don't actually have to show the next step. You can. If I did, it would just look like one long polynomial. Okay, so you don't have to. If you want to get in the practice of doing it, you can. But really what you're doing is just collecting like terms with the sign in front. So 7x plus 3x minus 2x. The only way we can take that sign in front is because this is a plus. When we're subtracting, we won't be able to do that. But our final answer, so if I circle it here, should get the same thing. So 7 plus 3 minus 2 is 8x. And then minus 4 plus 10 is 6, plus 5 is 11. So negative 4 plus 10 plus 5. Okay. Okay, so always check. Between the brackets, is it adding? It is. If there was nothing between the brackets, remember that means multiplying. But this is adding. We'll do multiplying next week. So this will be the same as 2x minus 4 plus 3x minus 2 plus 5x plus 8. When we add those together, 2x, I'm just going to make sure I don't get confused here. So 2x plus 3x plus 5x is 10x. Negative 4 minus 2 is negative 6, plus 8 is plus 2. Okay, so next one are two trinomials added together. Again, you can copy it out, or you can just look at the x squareds, plus in front. Okay, and then the x's and the constant terms. So 5x squared plus 10x squared is 15x squared. 4x minus 10x is negative 6x, so we showed it as minus 6x. And 9 minus 3 is 6. Okay. Again, adding, so nothing changes. You can just add right away. So we've got x squared, x and x, constant and constant. So that's 7x squared plus 14x plus 3. Okay, so x squared y with x squared y. xy with xy, y squared with y squared. So 7 plus 8 is 15, x squared y. 3 minus 1 is 2, xy. And negative 2 minus 1 is negative 3, so minus 3, y squared. Notice the degree. Degree 3, degree 2, degree 2. Okay? So the degree 2 you could switch around, but again, this has an x in it, so I'm going to put that term first. Next one, take a look here. We're adding everything. Often in all of these brackets, the first term was positive. This one's negative. Just means you're going to subtract. Okay, so so that's so m squared, m, and constant, okay? So 10 minus, when you add a negative, it's like subtracting, so 10 minus 3 is 7. Then negative 8m plus 15m. You can do the constant next, but put it at the end, descending order of degree. So that's plus 7m, and then plus 3. Okay, so subtracting is a little bit different. When you remove the brackets by subtracting, every term inside the subtraction brackets, so that'll be the second set or the third, however many you're subtracting. So when you subtract every term, the signs are going to change. So the signs inside the subtraction brackets will change. These ones, I need you to write out that first line of work, okay? So without the brackets. Adding, we didn't have to. This one we do. So here, the first bracket is not going to change when I rewrite it because there is nothing in front, so it means it's positive. Now when I'm subtracting a squared, it's going to be a subtracting. When I'm subtracting 6a, positive 6a, it's going to be subtracting. When I'm subtracting negative 11, it's going to be adding. So you need to be careful of those signs. So if the first term is positive, it doesn't look any different, right? But this does. So be very, very careful. So it's kind of a silly analogy, but I think about, okay, if you go to the grocery store with your mom, let's say, and you fill up a cart and you put 20 chocolate bars and 15 bottles of pop in your basket or your cart. Then you go meet your mom at the checkout, and she says, no. You need to take out 18 chocolate bars and 10 bottles of pop. So you need to take out and put back in the store 18 chocolate bars and 10 bottles of pop. Okay? So that's what you take out in your cart. Go put it back on the shelf. So really what you're doing is you're taking 18 chocolate bars off of the counter and 10 bottles of pop. You're subtracting both of them. So a big mistake is people will add this term. But it's subtracting a positive, which is subtracting a positive, which is subtracting. So you must distribute that subtraction. Oops. Okay, so next one. Let's move this up a little bit. I'm going to rewrite it. So the first bracket doesn't change. Now I'm subtracting positive 4t squared, so that's subtracting. Subtracting positive 10t, which is subtracting. Subtracting negative 6, which is adding. Okay, now I collect like terms. So the 3t squared minus 4t squared, negative 12 plus 6, no like terms with the t term. So descending order of degree, I'm going to start with t squared. 3 minus 4 is negative 1, but we don't have to show the 1. Constant term, that's going to go at the end. Negative 12 plus 6 is negative 6. And negative 10t will look as subtract 10t. To put it in descending order of degree. Okay, and then C, same thing, nothing in front, so we just copy that out without the brackets. Adding here, so nothing changes. Subtracting does, so subtract 5x, okay, and subtract plus 8 is subtract 8. Now your x term, x term, x term, constant, constant, constant. So, take a look here. 2x plus 3x is 5x. Minus 5x is 0. Right? 10 minus 10 is 0. 100 minus 100 is 0. 5x minus 5x is 0. So we don't show an x term. So then, negative 4 minus 2 is negative 6. Minus 8 is negative 14. So there are no x terms in that one because they add to 0. Okay, so turn over the page and you work on the next 3. Some of you are asking about D because there's actually a negative as the leading term there. So the first bracket doesn't change, but then remember, so you're subtracting a negative there. Usually it's a positive, so it looks like a subtracting, but here subtracting a negative, remember, is adding. So we want to always convert it to one sign in between the terms. Then subtracting a negative is adding again, and subtracting a positive is subtracting. So now that's what you collect like terms with. So the m squared and m squared, the m's and the constants. So that's going to be 13m squared. Then negative 4m plus 8m is plus 4m. And then 3 minus 3 is 0, so we don't show any constant term. Okay, in E, nothing in front of the bracket, so you just copy out whatever is inside the brackets. Then you're subtracting a positive, which is subtracting. Subtracting a positive, which is subtracting. Subtracting a positive, which is subtracting. Okay. So m squared, m, and constant term doesn't have any like terms to it. Okay, so negative 1 minus 8 is negative 9m squared. 9m minus 9m is 0, minus 2. Okay, so 9m minus 9m is 0m, which you don't even show. Okay, and then F, again, the first bracket, nothing changes when you get rid of the brackets. Then subtracting a positive is subtracting. Subtracting a positive is subtracting. Subtracting a negative is adding. Here, subtracting a negative is adding. Subtracting a negative is adding. And subtracting a positive is subtracting. So, again, really good attention to detail. You have to be careful. So there's a d squared, a d squared, a d squared, a d, a d, a d term, and then a constant, constant, constant. So lots of like terms here. So 2d squared minus 1d squared is 1. 2 minus 1 is 1. Plus 5 is 6. Okay, be careful. Try to add and subtract from left to right. If you start taking negatives first over here or a term over here, you might subtract the wrong thing. So I just go from left to right. Then d terms, so negative 7 minus 10 is negative 17. Plus 1 is negative 16. So you show it as minus 16d. Then negative 8 plus 2 is negative 6. Minus 6 is negative 12, so we show it as subtract 12. Okay, now how do you check these? Really, by doing it again, one way of checking is you could let, in this case, d equal some number. Not 0, but maybe a 1. If you put 1 into all of these and simplified it using the order of operations, then put 1 into your answer, you should get the same thing. So kind of a lot of work, but it is a way of checking. Then the last two here are sort of application questions. So you're given the perimeter and the length of two sides. Find the length of the third side. So you're subtracting. Do you need to show a whole step or a whole equation, I should say? Well, it might be helpful. You might be able to figure it out without, right? Because if this is the whole perimeter, you're going to subtract 7x and subtract 5x. Here, you're going to subtract, the thing is, you're going to subtract a negative and subtract a negative. So that's where showing the work for it might help you. Because when you're looking at it, you might kind of forget to subtract a negative. So remember, perimeter is the sum of the sides. So our expression for the perimeter is 13x minus 7y. And that's going to be 7x minus 3y plus 5x minus 4y plus the missing side. unknown side. So to get this by itself, you need to subtract this bracket and this bracket. So therefore, the missing side, or unknown side, is the perimeter minus 7x minus 3y minus 5x minus 4y. And without brackets, we get 13x minus 7x is 6x, minus 5x is 1x, negative 7y plus 3y is negative 4y, plus 4y is 0, right? So it's just x. So check it out. Here you can check. So if this is x, x plus 5x plus 7x is 13x. Negative 4y plus negative 3y is negative 7y. So that's your unknown side. Okay. Same question. So this is a triangle. We're given the perimeter. Find the length of the missing side. So remember here in a diagram, the dashes mean they're the same. So I'm just going to label it. Okay. So now this has a question mark. So my question mark will be the perimeter minus each known side. So 8x plus 13 is the perimeter, minus 3x plus 4, minus 3x plus 4. Now, you could add 3x plus 4 twice, right? Double it, and then subtract, because they're exactly the same. But this is step by step. We'll do multiplying next week. So really, 8x plus 13 minus 3x minus 4 minus 3x minus 4. Okay, so 8x minus 3x minus 3x is 2x. 13 minus 4 minus 4 is 5. Okay. So that's your missing side. So that's adding and subtracting polynomials.